Add and simplify if possible. 16 over x squared minus 16 plus 2 over x plus 4. In this case, we have a denominator that is a binomial and is factorable. And so in situations like this, to find the LCD, it's important to factor both of the denominators. I'm going to rewrite the problem, but I'm going to factor the denominators. The first one, x squared minus 16, is a difference of squares. So that's going to be x plus 4 times x minus 4. The second denominator can't be factored. X plus 4 is prime. So I'm just going to write x plus 4. But I'm going to write it in parentheses. It's going to be useful for us in a few minutes. So we've got 2 over x plus 4. When we need to find the least common denominator, remember that we need to include each factor in each of the denominators the most number of times that they appear. So if we're trying to find the LCD, we can see in the first denominator there is a factor of x plus 4, and that factor also appears in the other denominator once. So x plus 4 has to be a part of our LCD, and it has to be a part of it once because in each of the denominators it appears once. Remember, we have to include the maximum number of times. So that's just 1x plus 4. Now, there's also a factor of x minus 4 in this denominator, and it doesn't exist in the other denominator, but we need to keep each factor in the LCD the maximum number of times that it appears, and in this case, x minus 4 appears at most one time. So our denominator is going to be x plus 4 times x minus 4. I want to point out in the first fraction, we already have the LCD, because the LCD is x plus 4 times x minus 4, and we've already got that there. So we don't need to do anything in that first fraction. But in the second fraction, all we have is an x plus 4, and the LCD is x plus 4 times x minus 4. So there is a missing x minus 4 that we need in that denominator, and we can get that by multiplying by x minus 4. But we know that if we multiply the bottom of a fraction by something, we also have to multiply the top by the same thing to get an equivalent fraction. So in this case, we multiply both the top and the bottom by x minus 4 to get our new fraction. I always like to write this using a different color so that it's clear what we started off with and what modification we made so that it had the LCD. All right, now we need to multiply out that numerator, the 2. So I'm going to keep the first one as it is because there's no multiplying we need to do in the top. But then in the second fraction, we can distribute that 2. 2 times x is 2x, and then minus 2 times 4 is 8. So that numerator is going to become 2x minus 8 once we expand it out. And now that we have all of the numerators expanded out, we can add the two fractions, which we do by adding the numerators. So we've got that 16, and then we also have the 2x minus 8 all in the top. And we have x plus 4 times x minus 4 in the bottom. We can combine like terms in the numerator. The 2x goes out front, and then 16 minus 8 gives us 8. So we also have a positive 8 up there, all over x plus 4 times x minus 4. Now to see if anything will reduce, we need to factor the top. We see that we can pull out a 2. If we do that, that gives us 2 times x plus 4 in the top. And in the bottom, we have x plus 4 times x minus 4. When we're looking to reduce, we notice that there is a common factor in the top and bottom of x plus 4. So we can cancel out those x plus 4s. And then in the end, we have 2 in the top and x minus 4 in the bottom. So our final answer is going to be 2 over x minus 4. It's not always the case that there's going to be something that we can reduce by. There's not always going to be a factor that we can cancel. Sometimes we'll get here, and that's going to be our final step. But in this case, there was something that canceled, so it's always important to factor the numerator in the end, just to make sure.